This puzzle is called 56 Killer by jsmirob, jsmirob. I'm not quite sure. I got it from the Sudoku testing submissions channel of the CTC community Discord. Let's take a look at the rules. So we just have one rule today. Standard killer cage rules. So digits in a cage add up to the given digit. So these two digits will add up to 6. These two digits will add up to 5. These to 9, and so on. And also, digits can't repeat in a cage, so I think this is the only one that matters for that. But digits can't repeat, so we couldn't have like 3, 3, 7, 7, or something like that. That technically does add to 20, but digits can't repeat. They said in the post that it was probably around a 2 out of 5 difficulty, if you want to give it a try. I'll put a link to the puzzle down in the description. Let's get going. So the first thing I see is just, there's only two ways to make 5 in 2 digits. It must be 1, 4 or 2, 3. And 6s must be 1, 5 or 2, 4. Okay. So what is that telling me? One thing I am seeing... Yeah, one thing I am seeing, which I don't know if this is the intended or not, but... So in row, what row is this? 4, we already have 3 small digits. And by small digit, I mean 4 or less. No matter how we arrange these, of course, they're going to be 3 of the 4 small digits. Well, how do we make 8? We're going to need one more small digit in here. Now, it doesn't have to be, it's not going to be both of them. I guess I can just color one of them. But it's either going to be 1, 7, 2, 6, or 3, 5. We're going to need the 4th small digit. We can't do it any other way. Like, we can't take 2 high digits and push them together to make 8. Like, that's just not going to work. Which means this 20 cage is going to be somewhat restricted. The minimum we can put in here, and we'll just have to remember that this is the minimum, is 5, 6. So we already have 11 along this side. Now, oh no, it doesn't quite work the exact same way. Okay, well this is almost the same. I thought this was also exactly the same and we were going to be able to like reduce this to like 5, 6, 7 and do something fancy there, but that's not quite what's gonna happen. So these 3 yeah, there's gonna be a 1, yeah, how should I say this? Combined with 8, we're going to use up 1, 2, 4, and 5. Because if 8 is, let's say, 1, 7, then this will be not 1, 5, and then this will have to be a 5 as the last remaining of the quadruple. If this was 2, 6, this can't be 2, 4, and then this will be a 4. So we've used up all the quadruple again, and again, if it's 3, 5, this can't be a 1, 5 because we just used the 5, so this must be a 1. So no matter what we do, we're using up the full quadruple. So this cell actually is a minimum of 6 because we can't use the 5 anymore. This could be the 5, and the minimum for this is 3, which adds up to 11, and that's not helpful. This can't be a 6 for multiple reasons. I thought I was onto something there. But the fact that the yellows are not quite as restrictive as the greens foiled me, I think. Okay. I did see one other thing. If we look at 8s, looking down into box 9, they're pretty restricted, and we can't actually put an 8 into a 9 cage either, so 8 must just go there. Which puts an 8 into one of these spots, in boxes 6 and 8. It could be A1, that's definitely possible, or it could be here. If it's here, then the 8 is over. Oh no, it could be an 8 right there. So we have an 8 up there, but that's not super helpful, I don't think. Let's get rid of these colors. I guess that was not the way to go. Maybe we need to look at Yeah, I don't know if this is what we need to do either. So this is one of the two pairs of that add to 5. So this is either 2, 3, or 1, 4. Now this pair down here, could these two pairs be the same? If this was 1, 4, could this also be 1, 4? Well, no, because this cell wouldn't be able to be filled because it sees both digits of 1 and 4. So green and blue must be a different pair. Similarly, could this be green? If this one was 1, 4, could green also be 1, 4? Well, this cell can't be 1 or 4, so it must be 2, 3. So the blues are going to be the same. The green is going to be the other one, and this one I don't know about. I don't see any way to connect it. I guess I do see this has to be 7 or 9. 7 or 9 has to be outside the 9 cage, for whatever that's worth. Okay, now let's look at the 6 cages. So we'll make this one pink, and this one yellow. And the same thing's going to happen. If we try to make them the same, let's make them all 1/5s, well then this cell can't be filled, because the 1/5 looks right over there. So pink and yellow must be different, and the same down here we have this other 6 pair looking up to pink. It can't be the same as pink either, because again, it would break the puzzle. So now we have these. Now what is... I'm hoping for some, I don't know. Hoping for something. So this, so whatever yellow is can't be in this cell. Or can't be in this cage. Yeah, okay, so that does help. That does help. This is where I should have looked right away. So whatever yellow is cannot be in this cage. We'll color it gray. Or, yeah, we'll just color it gray for now. Yellow cannot be in gray. No matter what yellow is, it's... This cell of gray sees these two, the right cell of gray sees these two. So what if gray was 2, 4? Well, now gray can't have a 2 or a 4 in it. And we've just broken the 5 cage, because that only adds to 4. So yellow must be 1, 5, which makes pink 2, 4. And now we remove 1 and 5. Well, 5 wasn't there anyway, but remove the 1 from the 5 cage. Then we have to remove the 4 because the 4 can't go with the 1. So this gray is a 2, 3, and yellow, and those are all done. Okay, now I think we can do the same thing with this cage over here, which will make gray. Gray cannot have blue in it. Whatever blue is, it's ruling itself out of all of gray. So what happens if blue... Whoops, that was not what I wanted to do. What happens if blue is 1, 4? Sorry, 1, 4. I was typing 2, 3 at the time, so my brain short-circuited a little bit. Okay, so if blue was 1 and 4, then gray can't have a 1 or a 4 in it, and now it's 2, 5. And gray is now broken. So blue can't be 1, 4, which makes it 2, 3. And then green must be the opposite, so it must be 1, 4. And now, let's look at this. It can't have a 2 in it, because it can't have a repeated digit in blue. So it must be 1, 5. Okay. I think that's good. Okay, now we've kind of finished that. I think that was the break-in. I thought I spotted the break-in with this 20 cage, but I was totally wrong. So let's look at this 8 cage now. It can't have a 1 or a 5 in it. It must be a 2, 6. And similarly, this 8 cage can't have a 2 or a 3 in it. So it must be 1, 7. And that's going to cause a lot of things to happen. So this can't be a 1, so it must be a 4. This can't be a 2, so it must be a 4. Okay, it caused less immediately than I thought it would, but that's okay. This now can't have an 8 in it, because it can't be... If this had an 8 in it, it would have to be 8, 1, but we already put the 1 in the box, so that's not going to work. We have not used the 1 in the box over here, so that's not as helpful. So what's the minimum for this cell? Can't be a 1, can't be a 2, can't be a 3, can't be a 4, can't be a 5, can't be a 6, can't be a 7, could be an 8 or a 9. Well, that is a pretty big digit. What about this cell? This could be a 3. Okay, well, let's just do it this way. What's left in this column We need 3, 7, 8, and 9. And these two can't be 8s. And this can't be a 3. Okay. Now what's left in this row is an 8 and 9, of course, and a 5 and a 6. Okay. Now, could either of these be 8 or 9? And the answer is no. If we start putting another really big digit in here, let's say 9 goes here, then this becomes 8. Now we have 17, and these two need to be 1 and 2, but we can't put a 1 in the cage anywhere. And even if we could put a 1 in the cage, the minimum for this specific cell is 3, which is already 20. Similarly, if we tried to put a 9 over here, then that's 8. And then we need to put a 5 in here, but that's 22. So we can't put another big digit in here. So this can't be a 9, this can't be an 8 or a 9. Like, we can even try it with an 8. So an 8 here. Oh, of course, that just can't be an 8. But even if it could be an 8, 8 puts a 9 there, which is exactly the same. It works either way, putting a 9 or an 8. Okay, and this can't be an 8. Or a 5. Okay. So now, what's the minimum we can put in here? Oh, we can put a 5. Let's see, a 5 and 8 was 13. Plus 3 is 16. So this is a 3 or a 4. 3 is the minimum that can be in there, but the maximum is just a 4. Let me do that math again. 5 plus 8 is 13, plus 3 is 16, plus 4 is 20. So this could never be a 7, because we only have one digit of leeway here, one degree of freedom, so to speak. And if we put a 7 in here, that's just way too huge. The minimum would be, the minimum here is 16, so 7 would bump us up to 23. So this must be a 3, makes this a 4. Removes 3 from there, but that's not too big of a deal. Guess we have 4 over there somewhere. So, what do we do now? We have 7. Oh, and the degree of freedom was this 4. It was 3 or 4, so we took the degree of freedom. So now it's 5, 8 here. This can't be 5 or an 8. This can't be an 8. And this adds to 20. There we go. Perfect. Okay, what about this 9 cage? I'm just looking down here. There are 3 options for 9. I'm just going to type them into the box here. Whoops. Just so we can see them. I don't want to bring up Notepad because I don't have it open already. So we have these 3 options for 9. 1, 3, 5, 1, 2, 6, 2, 3, 4. But it cannot be 2, 3, 4 because we already have a 2, 3 in the box. Now, you might notice one very similar property between these two. It's always going to have a 1. So, long story short, this cage always has a 1, which makes this a 5, which makes this a 1. Now, we have a 2, 3, and a 1 here, which means this cage cannot have an 8 in it. But more importantly, it must be 4, 5, because it can't be 1, 8, can't be 2, 7, or 3, 6. So this is 4, 5. We now have 4, 5s looking into the middle box, so 4, 5 must go like this. And the last 2 remaining digits are 3 and 9. 1, 2, yep, I think 3 and 9 is correct. So that looks good. Okay, what are the options for this cage? It can't be 1, 8. I think it could be 2, 7, at least for the moment. Could be 3, 6. Can't be 4, 5. So now we have one of 2 options here, but we have a 2, 3 looking over. So that's going to remove some options there. Okie dokie. Guess there's a 4 down here somewhere. What's left in this? Oh, no, there's a couple options. I was thinking this was a pair, but it's not. But in any case, 4 must be in one of these 2 options, or one of these 2 cells. That's the only spots left, so this must be a 5, this must be a 4. Okay. Oh, this can't be a 1. We have a 1, 5 looking down. So the 1 is vertical here, for whatever that's worth. Oh, we have a 5 in the cage, and I don't know why I skipped on that logic. So I said the 2 options were 1, 3, 5, or 1, 2, 6. Then immediately typed a 5 in here and just stopped thinking about it. Of course, this 5 comes in here, and stops the 9 cage from being a 1, 3, 5. So it must be 1, 2, 6. Now we have a 2 looking over here, so this can't be a 2. Which means we have a 2 in one of these two cells. Which means that this can't be a 2. So this must be a 3. And this must be a 6. Makes this a 2, makes this a 3. And what's left out here is 4, 7, 9. Okay, so we have 4s forced into columns 8 and 9 over here. So we must put a 4 up here because it's the only spot left in the 3x3 box. And you must put a 4 down here because, again, it's the only spot left in this 3x3 box. So could we put a 4 here? If we put a 4 here, then this would be a 4, and then we would have nowhere to put a 4 in yellow. So, in fact, this can't be a 4. So this is a 5, this is a 4. And let's just get rid of these colors real quick. What's left here is 6, 7, 9. One of them must be a 7. That's fine with me. Oh, and we can do the same thing horizontally. We have pencil marked 4s right along here. So could this actually be a 4? We'll put a 4 here in pink, and then have nowhere to put a 4 in yellow. So, in fact, this can't be a 4. So 4 must go up there. This must be a 7 or a 9 then. Oh, we have a 3 looking up, so this must be a 3, this must be a 9. Okay. Okay, what can this... Oh, we have a 6 now, so this must be a 1. We have now a 2-6 pair looking to the left. I'm a bit slow today, I think. That was just not... I should have spotted a couple of things here much faster, I feel like. So we have a 2-6 here looking over to the left. So where can we put a 6 in box 7? We can't be an 8, and we have a 6 looking down, so this is a 6, this must be the 4, which means that can't be a 4. Now this 6 looking up means this must be the 9, makes this a 6. Okay. One of these two must be an 8. Do we know anything about this? A little bit. So we have a, whoops, we have a triple here, 4, 7, 9 triple. 4 must go down there in box 9. So what's left is a 1 or a 5, and in fact we have a 1 up here, so this must be a 5. And there we go. So what's left in this box is 7, 9, and 1. Is that true? Yes. Well, actually we can just use that 1 again, and put the 7, 9 like that. We still don't have a 7 or 9. Look, we have all these 7s and 9s. I don't see a way to figure them out quite yet, though. Actually, I just spotted a way to figure them out. Where does 9 go in box 1? We have this 9 looking up. So 9 must be in one of these two cells. Of course, it can't be in the same column. So now, we have these 9s looking over into row 2. Could this be a 9? Well, no, because that would rule 9 out of box 1. So we put a 7 there, and now we can resolve all the 7s and 9s that we want. This must be a 7. This can't have a 7. Makes this a 9, 7. Now we have 7s looking up like this. And in fact, this 9 looks back down to this 4, 9. And then resolves those 4s. I think that's all the 4s now. 9 must go here. And this 6 looks down to resolve this cage down here. 2, 3 is not resolved. That's fine. We have a 2, 3, 6 left in the column. And this 6 means this can't be a 6. So this must be the 6. Then this 2 looks over and says this must be a 3. So now this is a 2, 7 pair, but we can use that same 2 again. So that's a 2, 7 like that. Why isn't this side so handy as the other side? We resolved it all up, and this one's still looking... We need some help. This must be the 9. We now have a 9 over here, or... I don't remember when we got... Oh, that was the 7, 9 pair, of course. So that 9 is pushed over here, which means this must be a 3, 6, and we have a 3 right here, so this is a 3, 6, which resolves that. This 7 from the 7, 9 pairs actually resolved that earlier, which I missed. This must be a 1 in the box. This is the 2 for the remaining bit of the row. This is a 7, 8. Oh, this 2 looks down here. And then this must be a 7, 8 for the column. But we have a 7 right here, meaning that must be an 8. And now we are coming down home stretch. Maybe I talked badly about the left side of the grid. It did finish up itself pretty nicely. So this must be a 3, because we have the 3s there. This is a 5, 7, and we have a 7 up there. So that's resolved, which resolves that. Now we just have to place our final digits. We already have a 5. No, we need a 5. We need a 6, we need an 8, and then we need a 9. There we go. That wasn't too difficult. Yeah, that was 2 out of 5 probably. Easier side of 5. Easier side of 5. Easier side of 2, just like they said in the post. But yeah, that was a fun killer with a focus on the 5s and 6s at the start. Good job to, oh my gosh, I should really figure out how to pronounce this. jsmirob for this puzzle, and thank you all for watching.